What's going on, guys? We're going to talk about glycogen. So some basic info is the more branches of glycogen on glycogen, the more sugar it's going to have, which is kind of obvious. In the liver, it's broken down for blood glucose, and in the skeletal muscle, it's obviously used for muscles. In the liver, it has the GLUT2 transporter, which is bidirectional, which we've talked about, and also has glucokinase. And then for the skeletal, it has the GLUT4 and also insulin, and it has hexokinase. The way I think of hexo is hexo like flex, and when you flex your muscles, so that's why. Some more info. The hexokinase versus the glucokinase. Hexokinase is in most tissue. The glucokinase is mainly in the liver and pancreas. Hexokinase has a low Km, and then glucokinase has a high Km. So it takes a larger concentration to activate each one. Glucokinase is induced by insulin. It's controlled by the GKPR. So that's when sugars are high, it pulls the GKPR in. And then hexokinase is inhibited by G6P, or glucose 6 phosphate. So in glycogenesis and in glycogenolysis, pretty much goes through this cycle. So we have glycolysis is like a frame point. And so we go down to glucose 6 phosphate, and then we come over by phosphoglucomutase, and that will give us glucose 1 phosphate. From there, we we use UTP to get UDP glucose, and from UDP glucose, we use glycogen synthase and the branching enzyme to make glycogen. Okay, so that's pretty much glycogenesis. The opposite would be we use a debranching enzyme to get to glucose 1 phosphate. It uses the same enzyme, phosphoglucomutase again, to get back to glucose 6 phosphate. And then from glucose 6 phosphate, we use glucose 6 phosphatase to get back to glucose, which is the beginning of glycolysis, right? So technically this should be written as glucose, not glycolysis, but the branching enzyme would be responsible for forming branches, and then the debranching obviously would be in charge of breaking down those branches. So let's talk. So just to top off with glycogen lysis, we degrade glycogen, and we use glycogen phosphorylase that cuts the glycogen, and then we use the debranching enzyme, which is all part of this part up here. And then we use glucose 6 phosphatase to go from glucose 6 phosphate to glucose. And then from there, glucose is transferred throughout the body. So let's go to the regulation, which is this guy. So there's a couple things that we need to understand is there's phosphorylation, and in the videos he talks about it being an on and off switch. So in genesis we have synthase, right? We're going to be building up, and then in lysis we have phosphorylase. We also have allosteric regulation, which is like a dimmer switch. And then we have all enzymes are either phosphorylated or dephosphorylated. So they're either on or off, pretty much. So the best way for me to describe it is through this like hormonal thing. So glucogen, if we have low blood sugar, it means that we need to cause phosphorylation to happen so that we can clip the glycogen. And insulin, if it has insulin, we're going to have a higher blood sugar, right? Because we need that reaction to happen between the two, which causes dephosphorylation, which would result in building up glycogen. And then the last hormone that we talk about is epinephrine, and that's if you have low blood sugar in the skeletal muscle, we want to break down glycogen. So we're going to use cyclic AMP, and that's the calcium comodulin, I think is what it was. So if you notice, low blood sugar, we're going to be phosphorylating. High blood sugar, we're going to be dephosphorylating. There's another thing called the insulin glucogen ratio. So if it's high, that means that insulin is high, which means that we have sugar in our body. So we don't need to use glucogen. But if it's low, that means the opposite, right? So the last thing we talk about is these defects. So for the first one, we have the Van Gierks. So think of the G for glucose 6-phosphate, and that's in the liver and the kidney. And this is the only one that's in the kidney. So that might be a test question. For the second one, we have the POMPs, POMPES. So it's kind of goofy. Think about there's 2 P's in it, so that's where you get the 2 from. And the P's are also the first and fourth letters. So it's going to be the first and fourth glucosidase. I'm probably mispronouncing stuff. This one's in the liver, the heart, and the muscle. We have the Cori cycle, or the Cori. This one's going to be in the 1,6, so this is the debranching enzyme. It's in the muscle and the liver. We have number 4, which is the Andersons. And so that's 1,4 and 1,6, it's the branching enzyme. So we have debranching and branching. So for the 5th one, I didn't write the name down, but it phosphorylates and it's the muscle. And this is the only one that does strictly muscle. So I wouldn't be surprised if we had that one pop up. And it's called the McArdle disease. And the last two I actually don't have the names for. So 6 is, again, phosphorylase, and 7 is phosphorylase, and these are both liver. So if I were to see any on the exam, it's going to be the McArdles, which is muscle, so think McArdle, muscle, so M&M. Then we have the POMPs, which is 1,4, or the Gierks, which is the kidney and liver. That's what I would expect to see on the exam.